In this video, we're going to work on what are called advanced fraction problems or complex fraction problems. And basically, this is just taking the stuff that we've talked about with fractions and equations and expressions and taking it up a notch, putting everything into fraction form and making it just a little bit more difficult. So that's okay. We're going to take it step by step. We'll work through it. Okay? The first example we have here, okay, is a complex fraction problem. And as you can see, we've got 4 different fractions in a fraction. Okay? My first step for you guys for this problem is to find a common denominator on the top and the bottom. That's going to be necessary for us to get one fraction over one fraction. We know how to divide that. Okay? The first thing I see here is this x to the minus 1. It can be flipped into the denominator of its individual fraction. So I'm going to do that real quick. I'm just going to take it and put it back down here. Okay? And this b here can do the same thing. I'm going to move this b down as well. Okay? Now that I've done that, everything is a positive exponent. It's just going to be a little bit easier for us to work with. Okay? The next thing I'm going to do is make this 4 a fraction as well. 4 over 1. That's still just 4, but since we're dealing with fractions, we want everything to look the same. Okay? Now we need to find a common denominator for the top and the bottom. On the top, our common denominator is going to end up being 3bx. It's the highest multiple in the problem. So what I'll need to do is multiply everything on this side by 3b over 3b. That's going to get me the common denominator I need, and I'll write that out now. So I got ay over 3bx minus 2a, making mistakes, 6ab over 3bx. Okay, that's our top part. On this side, okay, this is missing an xb in the denominator, so we're just going to multiply both sides by xb over xb, and that'll give us the common denominator we need. So we'll end up getting 4xb over xb minus a over xb. Now that we have common denominators, we can combine the top and the bottom so that we have just the one fraction over one fraction. So I'll do that down here. I'm going to end up with ay minus 6ab over 3bx over 4xb minus a over xb. Okay? This is a division problem that we can solve. We have a fraction over a fraction, and we know how to solve those. We're going to flip the bottom one over and then multiply. So I'm going to do that right here. Just rewrite that bottom one upside down. And I have this now. I've got ay minus 6ab divided by 3bx times xb over 4xb minus a. The cool thing is, now that we've set this up, is that when you multiply two fractions together, you can cancel things as long as there's not a plus or a minus sign in there. That plus and minus sign is keeping that thing as a unique term. But as you can see here in 3bx and xb, those things have similar factors, similar parts of the terms, and we can cancel those things out. xb over xb is 1. So if I cross those out, I can now multiply, and I've simplified the problem. So I'll end up getting on the top ay minus 6ab over, got to multiply by distributing this in, you're going to get 12xb minus 3a. Okay? Nothing can reduce at this point. There are minus signs in between the terms. They're done. This is our final answer. Okay, so as you can see, there's a step-by-step process for these advanced fraction problems. You need to find common denominators on the top and the bottom. Okay? Once you do that, you need to combine those top and bottom terms so that you get one fraction over one fraction. And then you divide and simplify, and you can get your correct answer. The other example over here I have is very similar to this one, except in this instance it's going to look like this. And this is a very confusing problem when you first confront it. Because you look at it and you're like, this can't be an advanced fraction problem, there are no fractions. That's not true. All of these can be written as fractions. So let's quickly convert this into fractions. A to the negative 1 is 1 over a. This is b over a to the third. And this is b squared over a. Okay? Now we have a complex fraction problem. It's very similar to this one. We need to find common denominators and move from there. So, for this one here, our common denominator is a to the third. So I need to multiply this by a squared over a squared to get my common denominator. And down here I only have one term, so I don't need to worry about common denominators at the bottom. So when I do that, I'm going to end up getting a squared over a to the third plus b over a to the third equals b squared over a. Okay? Good start, a good place to be in. Now we're going to combine our like terms. We can add them up, and so we'll get a squared plus b over a to the third divided by b squared over a. Now we have a divisible fraction, so I'll flip this one over, get a over b squared. Okay? Once again, a and a to the third can reduce because it's a multiplication problem and they're like terms. So this can become an a squared, this can go away, and now I've simplified and I can continue on with my problem. I'll end up getting a squared plus b on the top and a squared b squared on the bottom, being my final answer. So as you can see, problems that look like they are not complex fraction problems can be if they have negative exponents. And once you've made them fractions, it solves just like any other complex fraction problem. Okay? As far as we go in Algebra 1, this is about as complex as it's ever going to get. Okay? So if you can complete these problems, you'll be able to do anything that the book throws at you.